10.4, number 3, we've got a projectile is fired with an initial speed of 500 meters per second and an angle of 45 degrees. Here's our projectile, and a few questions to answer. So, when will it strike? So we could figure out what the vertical component of this is, make it in vector form, and then find out when it goes up and then when it's back down, and that'll be when it strikes. So we could do this without any formulas. And how far, we could figure out the x component. You know, once we have the time it takes to go all the way back up and back down. Let's say it takes 20 seconds, and we'll have how far it goes. But there are formulas that are given to you if it's, as long as it's ideal projectile motion, which means it's going up and down, and it starts at the horizontal, like on ground, goes up and back down, lands on ground, which this scenario is. So the first question is flight time. We can just say the flight time is 2 times its speed times the sine of the angle over gravity. So in this problem we've got 2 times the speed, which is 500, times the sine of 45. So the sine of 45 is square root of 2 over 2, all over gravity, which is, we're in meters, so it's 9.8. So plug all that in. I think we get 72.15 seconds. Alright, so how far, we have another formula, the range formula. So the range is equal to the speed squared over gravity times the sine of 2 times the angle. So our range is 500 squared times the sine of 90, because it's 2 times theta. Sine of 90, or 5 over 2, is just 1, over gravity, which is still 9.8. So do all of that, we get 25,510.2 meters. Alright, so that's just plugging in formula. Again, you could do it without the formula, but a little bit easier if you have the formulas. How high when it's 5 kilometers downrange? So we know it's 5 kilometers, that's 5,000 meters. And in this problem, everything up to this point has been in meters. We know our x equation is always the initial velocity cosine of the angle times t. In this case, we know our horizontal distance is 5,000. Our initial velocity or speed is 500 times the cosine of 45 degrees, which is square root of 2 over 2, and then times t. So divide by 500, divide by square root of 2 over 2. Our time is 10 square root of 2. Okay, so we know that when the projectile is 5 kilometers downrange, it is 10 square root of 2 seconds. We want to know how high it is at that point. Okay, so we have the time in which it occurs. Now we need to know the y, the height. So our y equation is v sub 0 sine alpha t minus 1/2 gt squared. So from that, y is equal to 500 sine of 45 is square root of 2 over 2 times our time, which is 10 square root of 2 minus 1/2 gravity times t squared. So simplify all of that, I think you get 4,020 meters. So 5 kilometers downrange, the projectile is still 4,020 meters high. And then the last thing, maximum height. So we could find well, again, we could do this different ways, but there is a maximum height equation. So the y max would be v sub 0 sine alpha squared over 2 times gravity. So just using that formula, we could do 500 times square root of 2 over 2, that amount squared over 2 times 9.8, which is about 6,377.55 meters high.